online classes. My name is James Kenyani. In this lesson, we are going to introduce a new topic, SADS. So before attending the lesson, the learner should be familiar with the expressions written in root form, which were discussed in Book 2. So revision of square roots and cube roots is necessary. In this topic lesson, the learner will be introduced to rational and irrational numbers. The objectives of this topic are: 1, the learner should define rational and irrational numbers. 2, the learner should simplify expressions with SADS. And lastly, the learner should rationalize the denominator. But as they say, you cannot chew a lot once. That's why in the first lesson, we are only going to look at rational and irrational numbers. The main objective, so the lesson is rational and irrational numbers. Rational and irrational numbers. Rational and irrational numbers. So in this lesson, the main objective is for the learner to differentiate between rational and irrational numbers. Rational and irrational numbers. So that is the objective. So we begin with rational numbers. Let's begin with rational number. So a rational number is a number So learner, as you look on the board, a rational number is a number which can be written in the form of P divided by Q, where Q is not 0, and there is no common divisor of the numerator and denominator, except one. So numbers like 2, we have 2, a half, 3/4, square root of 4, cube root of 8 are rational numbers, are examples. And it is true from what we saw that there's no common divisor of the numerator and if we have a denominator except 1, 3/4, 1/2. We are also told terminating decimals and recurring decimals are also rational numbers. So terminating decimals like 0.2, 0.125, 0.375 are rational numbers. And one would ask why? Why the case? Because if you write 0.2 as a fraction, it is 2 over 10 learner. 2 there goes there 1, 2 goes there 5. If you write 0.25, 125 as a fraction, it is 125 over 1,000. 125 goes there 1, 125 goes there 8. If you write 0.375 as a fraction, learner is 375 over 1,000. 125 goes there 3, and there it goes 8. You see, you get rational numbers. You get a rational number. It can be written in the form of P divided by Q. We are also told recurring decimals like 0.3. When I put a dot there, you can write those 3's to the end of the world. To the end of the world, comma, 0.166 is recurring, are rational they are rational numbers. They are actually rational numbers because 0.3 converting to a fraction is 1.1 over 3, a rational number. 0.16, 6 recurring, works to 1 over 6, works to 1 over 6. So that's why the recurring decimals also get into that category. Now we shall look at irrational numbers. Irrational numbers. So you find when we shall be dealing with the topic, most of the numbers will be written in root form, either square root or cube root. And you find most of the rational numbers, they had a perfect square or a perfect cube root. Let's look at square root of 4. What is square root of 4? It is 2. What is the cube root of 8, learner? The cube root of 8 is 2. So you'll find most of the rational numbers, they'll have the perfect squares or perfect cube roots. When we come to irrational numbers, most of them will not have a perfect square or a perfect cube root. So examples of rational numbers are, and I'm going to give examples from 0 to 10, where we have the third or the root form, are square root of 2, square root of 3, square root of 5, square root of 6, and square root of 8, square root of 9. There is something you discover. Like 1, the square root of 1 is 1. The square root of 4 is 2. The square root of, so this is not there. It is supposed to be square root of 7 and then square root of 10, learner. So you realize square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So between 1 and 10, these ones don't have the perfect square root. You realize all of these irrational numbers do not have a perfect square root. Do not have a perfect square root. They do not have a perfect square root. You are also told pi is also an irrational number. Is also an irrational number. When you express it, it is 3.142. It doesn't occur in the recurring decimals. It doesn't occur in the recurring decimals. So just a recap of what we've done, what a rational number would be. A rational number can be expressed in terms of P and Q, where Q is not 0, and there is no common divisor of the numerator and the denominator except 1. And I've given examples where we had the root form like cube root, it was perfect. But now we also included the terminating decimals and recurring decimals. So the only difference when we come to irrational numbers, most of them that would occur in the root form, like square root, they do not have the exact or the perfect square root. They do not have the perfect square root. So in the assignment, so learner, in the assignment, you'll classify the following as irrational or rational number. Irrational or rational number. We have square root of 11, square root of 8, square root of 16, square root of 25, fourth root of 32, fourth root of 16, and square root of 21. Note that, learner, where you'll get a perfect one, a whole number, that will be a rational number. Where you cannot get a whole number, that will be an irrational number. So thank you very much for the audience, and let's meet in the next lesson as we continue learning about surds. So thank you very much. Have a nice time. Let's meet in the next lesson. Bye-bye.
Enroll your child with the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Karibu sana mwanafunzi. Tuko pale pale katika masomo ya mtandaoni ya Manifested. Hapo awali tulikuwa tumeshashughulikia ushairi, tukaangalia baadhi ya istilahi zinazotumika katika mashairi. Lakini leo hii nataka tuweze kushughulikia mambo mawili. Hivyo basi lengo letu la leo ni kwamba kufikia mwishoni wa hiki kipindi uweze kuelewa kategoria mbili za mashairi na sifa zake. Jambo la pili ni kuelewa na uweze kueleza bahari mbalimbali za mashairi. Lakini hata kabla ya sisi kuelekea huko kwa bahari na kategoria, wacha tu kidogo tuweze kuangazia kidogo kuhusiana na yale ambayo tulikuwa tumezungumza hapo awali kuhusiana na ushairi, maana yake na baadhi ya istilahi. Iwapo unakumbuka, basi tukasema kwamba kumbuka somo letu la leo ni Kiswahili. Bado tuko katika mada kuu ambayo ni ushairi. Na nikawaeleza kwamba katika kile kipindi kingine tulikuwa tushapata maana ya shairi, ambapo tulisema ni utungo wa kisanaa wacha nitumie, ni utungo wa kisanaa wenye lugha teule. Lugha teule, naomba kufuta tafadhali. Unaotumia lugha teule mpangilio maalum wa maneno, unaotumika katika kuwasilisha ujumbe. Wanafunzi, kumbuka kwamba hivi ndivyo vitahiniwa. Unapoeleza dhana hii ya shairi, unapoeleza maana yake, kumbuka kutaja kwamba ni utungo wa kisanaa. Kumbuka kutaja kwamba unaotumia lugha teule. Sio lugha tu hivi hivi, lugha yote, la hasha. Ni lugha iliyoteuliwa kwa weledi mkubwa sana, tena zaidi, na mpangilio maalum wa maneno. Maneno yanapangwa kiasi kwamba yanaweza kuwasilisha ujumbe wa msanii. Na basi kazi yenyewe ya huu utungo wa kisanaa wenye lugha teule na mpangilio maalum wa maneno ni kuwasilisha ujumbe. Haya, hapo basi katika hicho kipindi bado tukaangazia baadhi ya istilahi. Istilahi, hili neno istilahi kwa kimombo naweza nikakwambia kwamba ni kama vile terminologies. Terminologies ama terms, yani ule msamiati ambao unatumika katika uwanja wa mashairi. Moja kati ya hizi istilahi ambazo tuliweza kuziangazia ni mishororo. Baada ya mishororo tukasema kwamba mishororo ni ile mistari katika ubeti, ni mistari katika mashairi. Umeangalia shairi tu ukaona kwamba limeundwa kwa mistari. Kuna mstari wa kwanza, wa pili, wa tatu, wa nne. Yani hiyo ndio ambayo tunaita mishororo. Hii mishororo ikiwa miwili, mitatu, minne, mitano inaweza ikaunda beti. Ukiwa mmoja utaitwa ubeti, zikiwa nyingi zitaitwa beti. Aya, tukaangalia tukaona kwamba mishororo hii pia inaweza ikawa na vipande. Kimoja tutakiita kipande, vikiwa vingi viitwe vipande. Na tukaona kwamba hivi vipande vinaweza kuwa kimoja, viwili, vitatu ama vinne katika mshororo mmoja, ambapo tulisema kwamba kipande cha kwanza kitaitwa ukwapi, cha pili kiitwe utao, cha tatu kiitwe mwandamizi, cha nne ukingo. Sio hizo tu, tuliangalia istilahi nyingine nyingi zaidi, ambapo na kutuma rejelea hicho kipindi ili uweze kufahamu zaidi kuhusiana na haya. Tukaangalia vina, tukaangalia mizani, tukaangalia manju ni nani, tukaangalia pia malenga, tukamwangalia shaha. Haya basi, nafikiri mwanafunzi umepata picha halisi ya yale ambayo yalishughulikiwa katika kipindi hicho ambacho kilitangulia. Haya basi, kwa leo nilikuambia lengo letu kuu leo ni kuangalia kategoria mbili kuu za mashairi, na kila moja yazo tuweze kujua baadhi ya sifa zake ili uweze kupata tofauti kamili. Zaidi tutaweza kushughulikia pia bahari mbalimbali za mashairi ya Kiswahili. Haya basi, wacha ni ufute huu bao tuweze kuanza upya sasa somo letu la leo. Kategoria za mashairi. msikilizaji, mwanafunzi, hili neno kategoria nafikiri unaona kwamba limetoholewa tu. Kategoria kutokana na neno category, na unajua category, kategoria ina maana ya aina. Hivyo basi tunazungumzia tu aina za mashairi. Sije kuwa ngumu kwako kuelewa kwamba tunazungumzia aina za mashairi. Mashairi yamegawika mara mbili kwa kigezo cha wakati na muundo wa nje. Kwa kigezo cha wakati na muundo wa nje. Aina ya kwanza ni haya mashairi tunayoyaita mashairi ya jadi. Mashairi ya jadi. Pia haya mashairi utapata pia yanaitwa mashairi ya arudhi. Yana neno jingine, yanaitwa pia mashairi ya kimapokeo. Ni mashairi ya arudhi, ni mashairi ya jadi, ni mashairi ya kimapokeo. Haya mashairi ni ya jadi, ni ya arudhi, ni ya kimapokeo kwa ajili ni mashairi ambayo yanafuata, ni mashairi yanayofuata kanuni au arudhi za utunzi wa mashairi. Wacha tu niandike kidogo hapa hivi kwamba ni mashairi yanayofuata kanuni au kaida au sheria za utunzi wa mashairi. Au kanuni, kaida, sheria za utunzi. Mashairi yoyote ambayo utapata kwamba yametungwa kwa kuzingatia kanuni, kaida, sheria za utunzi wa mashairi, hizo ama hayo mashairi ndio ambayo tunaita mashairi ya jadi, mashairi ya arudhi, au ukitaka mashairi ya kimapokeo. Ningependa uanze kujiuliza hivi, hizi sheria ama hizi kanuni, kaida hizi za utunzi wa mashairi ni gani? Hizi sheria ni gani? Kwanza, kaida zenyewe ni gani? Kaida zenyewe ni gani? Kwamba shairi lipangwe katika beti. Shairi lipangwe katika beti. Shairi lipangwe katika beti. Kuwe na kama unakumbuka katika hicho kipindi kingine tulisema kwamba ubeti ni fungu la ama ni kifungu cha mishororo. Ati sasa shairi linafaa liwe na ubeti wa kwanza, wa pili, wa tatu na kuwe na usawa katika beti zenyewe. Pia shairi lipangwe katika mishororo. Ubeti uwe umepangwa katika mishororo na mishororo yenyewe ijitosheleze kimizani, kivina. Unaona? Shairi lipangwe katika mishororo. Yaani ubeti wa kwanza uwe na idadi fulani ya mishororo, ubeti wa pili uwe na idadi sawa ya mishororo kama ilivyokuwa katika ubeti wa kwanza, ubeti wa pili hivyo, wa tatu, wa nne, wa tano, jinsi hiyo. Ni sheria, ni kanuni, ni kaida ya utunzi. Hizo ndizo zinazoitwa arudhi. Aya, mishororo pia kuzingatia sheria ya mizani. Wanamapokeo waliamini kwamba lazima shairi lifuate hiyo kanuni ya kupanga kazi yako, mishororo iwe na idadi fulani ya mizani. Zaidi, wacha tuangalie kanuni nyingine ni vina. Shairi lako unapolitunga, wanamapokeo walipendekeza kwamba lazima liwe na vina. Na kama unakumbuka vina tulisema ni nini? Ni zile silabi za mwisho katika ukwapi au utao au mwandamizi au ukingo. Hizo silabi za mwisho. Wanamapokeo waliamini kwamba lazima hilo shairi liwe na vina. Pia suala jingine la kibwagizo. Mwanafunzi, msikilizaji, mpenzi wa mashairi ya Kiswahili, hivyo basi unapotunga shairi la kimapokeo, hakikisha kwamba umefuata hizi kanuni. Upange kazi yako katika beti, katika mishororo, mizani, vina na kibwagizo. Hiyo ilikuwa ni kategoria ya kwanza ya mashairi, ambayo ni mashairi ya jadi, au kitaka arudhi, au kitaka mashairi ya kimapokeo. Malenga ambao wanafuata huu mkondo wa utunzi wa mashairi haya wanaitwa wanamapokeo. Wanamapokeo. Wanaitwa wanamapokeo. Yaani ni malenga. Ni wale malenga ambao hufuata mkondo wa kutunga mashairi kiarudhi. Hufuata ule mkondo wa kutunga mashairi kiarudhi. Kiarudhi kumaanisha kwamba wanafuata zile kaida, kanuni, sheria ambazo ni za beti, mishororo na mizani. Kategoria ya pili. Kategoria ya pili ni mashairi huru. Mashairi huru. Mashairi huru. Angalia neno kwamba ni huru. Ya? Wakati huu mwingine tulisema kwamba ni mashairi yanayofuata kanuni au kaida au sheria. Haya mengine unasikia ni mashairi huru. Basi bila shaka unajua kwamba ni huru, kiasi kwamba huyu mtunzi, huyu malenga anayetunga haya mashairi ako huru kuwasilisha maudhui yake, ujumbe wake, bila ya kubanwa na kanuni yoyote ile. Yeye si lazima beti zake zikawa na idadi sawa ya mishororo, si lazima kazi yake ikawa na vina, si lazima kazi yake ikawa na mizani ambayo inatoshana katika kila mshororo. La hasha, huyu ako huru. Na basi haya mashairi huru unaweza ukasema kwamba ni mashairi yanayotungwa bila kufuata kanuni au arudhi. Na ndio maana unapata kwamba kuna baadhi ya wataalamu mbalimbali unapata kwamba wako na visawe vya hili neno mashairi huru. Basi utapata kwamba pia huitwa, utapata linaitwa mapingiti. Utasikia naitwa pia mashairi ya kimapinduzi. Ya kimapinduzi. Utasikia pia anaitwa zuhali, masivina na kadhalika. Hivyo ni visawe vya mashairi huru. Ningependa uweze kuelewa kwamba haya mashairi huru huwa yana sifa yake ya kipekee. Unapata kwamba ubeti mmoja unaweza kuwa na mshororo wa kwanza uko na mizani 13, mshororo wa 3 uko na mizani 6, mshororo wa 4 una mizani 17, mshororo wa 3 wa 5 una mishororo 4. Yaani kumaanishaje? Kwamba huyu mtunzi wa kimapinduzi hajabanwa na kanuni zozote za utunzi. Aya, Mwanafunzi, ningependa tuweze kuangalia sifa za kila aina, kila kategoria. Tuangalie sifa za mashairi ya kiarudhi ama mashairi ya jadi. Sifa za mashairi ya jadi, ambayo pia tulisema ni mashairi arudhi, ama ukitaka pia yaite mashairi ya kimapokeo. Na utapata kwamba haya mashairi huwa yanakuwa na sifa kama zifuatazo. Sifa ya kwanza ni yana urari wa vina. Urari wa vina, yani kuna ule mtiririko fulani wa vina, kuna mkondo fulani unaofuatwa na vina. Unaona, vina vinaweza vikatiririka ama vikabadilika, lakini kuna hiyo sheria ya kuhakikisha kwamba kuna ule urari ama ule mtiririko wa vina. Pia kuna sifa nyingine ambayo ni urari wa mizani katika mishororo. Unapata kwamba mshororo wa kwanza una mizani 16, wa pili una mizani 16, wa tatu una mizani 16, wa nne vivyo hivyo mizani 16. Huo ndio tunaita urari wa mizani. Basi kuna sifa ya mishororo. Mishororo sawa katika beti. Mishororo sawa katika beti. Unapata kwamba ubeti wa kwanza una mishororo minne. Ubeti wa pili una mishororo minne. Ubeti wa tatu una mishororo minne. Yani vivyo hivyo unapata kwamba mishororo ni sawa katika beti mbalimbali. Zaidi unasikia kwamba pana uwezekano wa kuwa na mishororo kifu. Hii ni mishororo ambayo imejisimamia kimaana. Haihitaji ujumbe kutoka kwenye mshororo unaofuata. La hasha. Mishororo kifu. Ama pia utasikia ikiitwa mishororo toshelezi. Mishororo inayojitosheleza kimaana. Hivyo basi, msikilizaji, mwanafunzi, mpenzi wa mashairi ya Kiswahili, nafikiri umeweza kuangalia ukaona kwamba haya mashairi ya kimapokeo, mashairi ya arudhi, mashairi ya jadi yana sifa kama zifuatazo. Yana ule urari wa vina, urari wa mizani katika mishororo, mishororo inakuwa sawa katika beti, pia kuna mishororo kifu au ukitaka mishororo toshelezi. Naomba pia nikupeleke moja kwa moja hadi kwenye sifa za mashairi ambayo ni huru. Pia tuliyaita mapingiti, iwapo unakumbuka pia tukayapa jina kama vile zuhali, masivina au pia ukaita ya kimapinduzi. Sifa za mashairi ya kimapinduzi. Mashairi ya kimapinduzi, mashairi huru. Haya mashairi ambayo ni huru, kama nilivyowaeleza pale hapo awali, ni kwamba malenga wake hajabano na zile kanuni za mashairi ya arudhi. La hasha. Hivyo basi sifa ni kama zifuatazo. Utapata kwamba haya mashairi hayana urari wa vina. Hayana urari wa vina, hayana vina kabisa. Pia utapata kwamba haya mashairi hayana ule urari wa mizani. Unaweza ukapata kwamba mshororo wa kwanza una mizani 10, mshororo wa pili una mizani 7, mshororo wa tatu una mizani 16 ama 13. Vivyo hivyo. Yani hakuna ule mpangilio. Pia mishororo si sawa katika beti. Mishororo huwa sio sawa katika beti. Yeah. So nafikiri unaweza kupata baadhi ya sifa, na kuna sifa nyingine ambayo ni huwa na mishororo, huwa na mishororo mishata, huwa na mishororo mishata. Naomba kuliandika hili neno hapa chini kidogo, mishororo mishata. Kidogo naomba kueleza hili neno mishororo mishata. Hili neno mishororo mishata, kama unakumbuka hapo tulipokuwa tukiangalia sifa za mashairi ya jadi, tulisema mishororo yake huwa kifu au ukitaka toshelezi. Basi wacha kidogo nieleze mishororo ambayo inaitwa mishata. Mishororo mishata huwa ni mishororo ambayo haijakamilika kiujumbe. Ni kinyume cha mishororo kifu. Mishororo mishata huwa haijakamilika kiujumbe. Ujumbe wake hukamilika katika mshororo unaofuata. Hata hivyo, ninaposema kwamba huwa na mishororo mishata, haimaanishi kwamba shairi zima lina mishororo mishata, la hasha. Ni mmoja kati ya sifa za mashairi ya kimapinduzi, ama ukitaka mashairi huru. Kumbuka hapo awali tulikuwa tushasema mambo kuhusiana na kwamba mashairi ya jadi huwa na mishororo kifu au toshelezi. Basi katika hii sehemu nyingine ya mashairi huru kunakuwa na mishororo mishata. Wacha kidogo nieleze hii mishororo mishata ni nini. Wakati ambapo mishororo kifu inakuwa imejitosheleza kiujumbe, hii mingine mishata huwa haijakamilika kiujumbe. Ujumbe wake hukamilika katika mshororo unaofuata. Ya? Nafikiri unaelewa hapo. Yaani ujumbe wake unakamilika katika mshororo unaofuata. Basi, na hata kama nimesema kwamba haya mashairi huru ama mashairi ya kimapokeo ya kimapinduzi huwa na sifa ya mishororo mishata, haimaanishi ati shairi lote lina mishororo iliyo mishata, la hasha. Inamaanisha tu ni moja kati ya sifa. Utapata tu kuna ile ambayo imejitosheleza, kuna mingine ambayo haijajitosheleza. Ujumbe wake unakamilika katika mishororo inayofuata. Nafikiri hapo mpaka hapo umeweza kutembea nami tangu mwanzo hadi hapa sasa ambapo tumeangalia sifa za mashairi. Mwanzoni tulianzia kwa kueleza kategoria za mashairi au ukitaka aina, ambapo tulisema aina ni mbili kuu. Aina ya kwanza ni mashairi ya jadi au ukitaka arudhi au kimapokeo. Kisha kuna aina ya pili ambayo ni mashairi huru. Pia tukasema yana visawi ambacho ni mapingiti, pia yanaitwa mashairi ya kimapinduzi. Pia utapata yanaitwa mashairi zuhali au masivina na kadhalika. Mashairi ya jadi ya kimapokeo tulisema yanafuata kanuni, kaida au sheria za utunzi wa mashairi. Basi malenga wa mashairi haya huwa amefungwa, amebanwa. Lazima kazi yake ipange katika beti. Hiyo ni sheria moja yazo. Lazima kazi yake ahakikishe kwamba mishororo ipo tena imefanana. Mizani yake ni sawa na vina na kibwagizo. Amebanwa na hizo sheria. Huyu mwingine anayetunga mashairi huru hajabanwa kwa vyovyote vile. Yeye anaweza akatunga mashairi yake bora yafikishe ujumbe, maudhui yawepo, atumie ile lugha ambayo ni teule, maneno yake ayapange kwa namna fulani ambayo itamsaidia yeye kupata ule ujumbe. Basi haya mashairi yanatungwa bila kufuata kanuni au arudhi. zile zinazotumika pale. Hatukuachia hapo, tulienda tukaangalia sifa za mashairi ya jadi, ambapo tulitaja urari wa vina, yanakuwa na ule urari wa mizani katika mishororo. Kuna mishororo ambayo huwa ni sawa katika kila ubeti, pia mishororo yake huwa ni kifu ama toshelezi. Zaidi tukasema vipi kwamba kuna sifa nyingine za mashairi huru, mapingiti ya kimapinduzi, zuhali au na kadhalika. Tukasema vipi haya hayana urari wa vina. Si lazima kazi yako kuipanga ati lazima vina viwe vimefanana, la hasha. Pia hayana ule urari wa mizani. Zaidi mishororo huwa si sawa katika beti. Na pia kunakuwa na matumizi ya mishororo ambayo ni mishata. Hivyo basi, msikilizaji, mwanafunzi, muda wetu unatupa kisogo, na kama nilivyokuwa nimeahidi kwamba nitashughulikia pia bahari za mashairi. Samahani tafadhali kwa ajili ya muda, wacha tupate hayo katika kipindi kingine hapa katika masomo ya mtandaoni ya Manifested. Lakini sitakuacha hivyo msikilizaji, sitakuacha hivyo tu bila kazi ya kufanya. Kazi mradi kwako ni hii. Nataka nikupe swali moja tu ambalo utalishughulikia. Swali lenyewe ni hili. Kazi mradi. Zieleze kategoria mbili kuu. Zieleze kategoria mbili kuu za mashairi, kisha utolee sifa. Utolee sifa kila moja. Shukran. Kazi hiyo iwe imekamilika katika kipindi kijacho. Asante, siku njema.
Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Welcome our learners. I hope you're doing well. Today we're going to talk about prepositions. And these are just words that we all know, but they're used to show position, they show the place, they show the direction. All right? So we have This is not a new topic. I'm sure you've encountered it in Form 1. You've also encountered it in primary. So these are just the same words, but now we're looking at functions, okay? Just like we did previously during our lesson on conjunctions, we look at functions. Now we're looking at also functions of what? Prepositions. But before we go to functions, we have we've said it's a word that is used before a noun or pronoun to show direction, position, or place. Okay, to show direction, position, or place. All right. We have different types of prepositions. So we have types. Before we go to types, let me just give you a simple preposition. We have on, we have under, we have beside. Okay, these are things we all know. Like the pen is on the table. Okay, the pen is on the table. So on has been used to tell us the position the pen is in. So when you go to types, we have simple prepositions. One word. In, from, in, on, at. So simple prepositions are made up of one word, e.g., under, in, on, at. Then we have number 2, we have complex. Complex prepositions are made up of 2 or more words, e.g., in front of, by means of, in accordance with. Okay, we have complex prepositions that are made up of 2 or more words, e.g., in front of, by means of, okay, in accordance with, and many more that can occur within 2 or more words, but the function is to tell us where something is, or maybe position, or the means that something used. All right, now let's go to functions now. Functions of prepositions. One of the functions is they show position. Okay, they show position. I include, for example, below, on, under, on top of, beside, below, okay, and many more. So that we say, we can have even opposite, okay, and then we have in, at, all right, her window is opposite the main gate. Examples, they show position: below, on, under, on top of, beside, below, opposite, in, at. Okay, her window is opposite the main gate. All right, so that's one of the functions. Number 2, okay, so they show cause or purpose. For example, on account of, because of, due to, out of, for. Okay, we were exempted from the exam due to the heavy rains. So we were exempted from the exam due to the heavy rains. Another function, remember we are looking at functions still. Okay, for example, with, without, by, from, out of. So that we have, we shall travel by train. Okay, so it's used to also show means or source, and those examples that show that, those prepositions that show that are with, without, by, from, out of. We shall travel by train. Okay, number 5, another use is to show direction. Direction, e.g. Okay, to show direction, e.g. towards and through. Okay, number 6. Okay, so we have to show destinations such as to, on to, so that we have I went to the market. Okay, I went to the market. Okay, and the last one. Is this to show distance away from something? For example, we have at. So we have she held it at arm's length. So she held it at arm's length. All right. So all those are uses of prepositions. We've looked that they can show direction, they can show destination, they can show cause and purpose, time, they can show the place at which something is, the position, the means, but the source. Okay, these are not things you don't know. These are things you already use, but now when we use them, okay, we know that we are looking at prepositions in their usage in sentences. All right, so let me give you one short exercise to practice on the same. Okay, so we have come to the end of our lesson. We have given you an exercise. I've given you an exercise to help practice on functions on prepositions, functions of prepositions, and you're supposed to fill in the blank spaces with a suitable preposition. So number 1, I have known her dash 3 years. Number 2, we always go dash church dash Sundays. This message was written dash ink. Who is the best dash mathematics? They live dash a farm dash Kericho district. Okay, so I hope you've understood what a preposition is and how it functions in a sentence. Next time we're going to look at something else. Have a nice time. Hello students, welcome to today's session of the Manifested e-learning platform. Today I'm going to talk about idiomatic expressions. Now, idiomatic expressions is a very key aspect in meriting, ensuring that you get a merit tick when you're writing a composition. In paper 3, we normally look at what makes that student score an A in that composition. We focus centrally on maybe the use of vocabulary, the use of variety of sentences, as I mentioned earlier. We also look at use of phrasal verbs, maybe description, and one of the other aspects that can ensure that a student gets a merit tick is by using idiomatic expressions. Not necessarily on every line, on every sentence, but at least you can throw one here and there, so that you can ensure that your composition is creative and sounds mature, shows that you have complete mastery of language, you have competent use of language, you have linguistic ability is a bit high. Now, it's very important that much as we are talking about idiomatic expression, don't just listen to this lesson only. Make sure that you also go research, okay? Do your own revision, you know, find other ways of getting more idiomatic expression that can help flower your language. Even when you're writing the composition, ensure that you include here, one here and there, in one paragraph, in the other paragraph, in the other paragraph, okay? So that you can ensure that your composition sounds grammatical and also creative. Another thing is that it also helps in speech. When you're talking to people, you know, when you throw an idiom here and there, it makes sense. It makes the other person know that you can use English as a normal way of expressing yourself. So it's an important aspect, not just in speech, but also in writing and also in use in everyday life. Okay, even when you're delivering your speech to some people, you know, when you throw in an idiom, it can drive the point home. All right, so it's not something that you can just learn and now put the books away. No, it's something that will help you when you're using it in everyday life. So idiomatic expressions . So these are expressions whose meaning is contrary to the individual interpretation of the words found in the phrase. For example, if we say bury the hatchet, okay, so we've said that it's a type of an idiomatic expression, but it doesn't mean that now you bury a hatchet, okay? It just means you stop, maybe you stop fighting, okay? Majorly stop an argument, stop quarreling. All right, so the meaning of the idiomatic expression does not, it is not directly, it is contrary to the direct interpretation of the individual words. All right, but it's a phrase whose meaning is different. It has a deeper meaning. All right, it's a phrase with specific meaning. So it is a phrase with a specific meaning. It is a phrase with a specific meaning. Let me give you some of the examples, and then we will do one exercise, and then we will see how we can use them even in sentences. So one example is, so one of our examples, these are several examples of what? Idiomatic expressions. Examples. This is M of okay. So one of our examples is close-fisted to mean mean, get into hot soup to mean get into trouble, no love lost mean to not like each other, have a ball to mean have a good time, steal the show to mean attract all the attention, hold your tongue to mean keep quiet, keep a straight face to mean not to smile, and then between a rock and a hard place to mean in a difficult situation. Again, when you're using them in compositions, make sure you don't use the ones that are overly used. All right, avoid the cliches. At least come up with new ones. You know, as you interact with more text, as you interact with more books, you will encounter different and new idiomatic expressions to help flower your language. So let's have at least a few examples in sentences. So a few examples in sentences. The teacher told the student to hold his tongue. During the graduation ceremony, we had a ball, meaning we had a lot of fun, as we always say. We had a good time. And then the teacher told the student to hold his tongue. The teacher told the student to keep quiet. And then there was no love lost between the two brothers, even after many years of staying away from each other, meaning the two brothers did not like each other. Okay, no love lost means to not like each other. So I want to, other examples could be, I was caught between a rock and a hard place after I sneaked out of school, or maybe something like we got into hot soup when we fought with each other, all right? And then maybe my father is a close-fisted person, to mean he is very mean. My father is a close-fisted person, to mean he's mean, among other examples. All right, so I'm going to give you 2 assignments. One, you will need to maybe answer, and then the other one, you'll need to use them in sentences, like we've done in the ones that we have on the whiteboard. Okay, so in the exercise, choose an appropriate idiom from the box and use it in the correct form. You're replacing the underlined words, all right? The 2 for question 1, Masika's lousy jokes irritated Njogu. So you choose one to replace the word irritated, okay? And then you use it in the correct form. For example, in example 1, Masika's lousy jokes irritated Njogu. The answer would be rub somebody up the wrong way. So Masika's lousy jokes rubbed Njogu up the wrong way. So you're supposed to use it in the correct form. So the 2 never quite agreed on how to invest in their money. Okay. Njogu doubtfully accepted Olwach's suggestion that they buy the plot. The plot. Number 4, the new factory was the latest unnecessary and expensive venture to be put in the area. So replace unnecessary and expensive venture. Okay. Number 5, unexpectedly, Mzee Ochiel decided to plan his own funeral. And number 6, the clown's performance caught great excitement and applause. So from the 5, okay, make sure you choose what? The best answer. You see 1, 2, 3, 4, 5, 6. So from the 5 that I've given you, I've already given you the answer to question 1. Choose the best one and make sure you write it in its correct form so that the sentence remains grammatical. All right? You're not just fitting and replacing. You're also ensuring that as you replace, you're using it in its best form. All right? Now, one last assignment and then we'll be done with idiomatic expressions. So in exercise 2, use the idiomatic expressions below to construct sentences of your own. So the question, sentence 1 is to speak volume, so you use that, all right? Number 2, to go down memory lane. Number 3, keep or lose track of. You can use either to keep track of or you can use either to lose track of. Number 4, to play upon somebody's sympathy. Number 5, a chapter of accidents. Number 6, take the bull by the horns. Number 7, bury the head in the sand. So use either, use all of them, not either, but use all of them to construct sentences of your own. All right. Having said that, we have come to the end of the lesson. I hope you have understood what idiomatic expressions are. They are expressions with specific meanings, such that you don't get the meaning of the idiomatic expression from the individual interpretation of the what? Of the words in the phrase. All right. And another thing is that we have given various examples, and you can use them to flower your language. You can also use them in speech. You can even use them in when you're delivering a speech to some people. So it's not something that can only help you in grammar, but also in composition writing, but also in developing your grammatical skills. All right. So have a wonderful time, and we'll meet next time.
Hello, Lana. Welcome once again to Manifested Online Classes. My name is James Kenyani. We are going to proceed with our topic on SADS. And today, having known about the SADS, we are going to look at simplification of SADS. Simplification of SADS. So the lesson is simplification of SADS. The main objective of the lesson is to make the learner to be able to simplify any given SADS. So the objective is to enable the learner to simplify any given SADS. So we do that by looking at examples. So in this example, simplify the following SADS. A, square root of 27. B, we have square root of 72. And lastly, we have square root of 125. So learner, we learned in the previous lesson, SADS do not have a perfect root. Like square root of 27. There's no whole number that can be the square root of that. That's why all of them qualify to be SADS. So when you have these, you look for multiples of 27. So for this one, when you simplify, you look for multiples of 27. 27, we have 9 and 3. So you'll come and write square root of 9. You'll say square root of 27 is equal to square root of 9 times square root of 3. But learner, you discover 9 has a square root. 9 has a square root. So this will work to 3 square root of 3. And that is the simplified form of that SAD. That is the simplified form of that SAD. So you look for the multiples. So if you have a number given like 27, we've broken it into square root of 9 times square root of 3. It is the same as square root of 27. So the 9 there has a square root. So you simplify it. Square root of 9, 3. But it is now that the 3, it is now the square root of 3 that qualifies the answer to be a SAD, because square root of 3 there does not have a perfect root. We move to the second one, learner. Square root of 72. Square root of 72, it qualifies to be a SAD because it does not have a perfect root. It doesn't have a perfect root. So you'll come and say square root of 72, learner. Square root of 72, learner, will be equal to square root of, you start breaking 36 times square root of 2. So in most cases you'll discover, because before we started the lesson, they said in book 2, we said in book 2 you should have done much on cube roots and square roots. So once you are given a number like here 27, you know within 27 we have 9 times 3. So in most cases you are taking out a number that has a perfect root outside the root sign, and that number is 9. So for our case here, this will work to 36 as a perfect root. Square root of 36 is 6 lana. So the simplified form of that surd is 6 square root of 2. It is 6 square root of 2. We come to see lana, and the same experience happens to be coming about. You look into that surd, you pull out a number that has a perfect root. In fact, 25, you will see it is 125 is 25 times 5. So you'll come and say square root of 125 lana is the same as square root of 25 times square root of 5. But 25 has a perfect root. 25 has a perfect root. So this will be equal to 5 square root of 5. So lana, that is the simplified form. Usually, in the root sign, you remain with a number that does not have a perfect root. It will always be that for it to qualify to be a surd. So let's go back to the little recap of how we've been finding the simplified forms. We look at the number, look at the multiples. If one of the multiples it will have a perfect root, like 9 times 3, you look and find 9 will have a perfect root. That's why it comes down as 3, and you remain with root 3, which qualifies the simplified form to be still a surd. We move to square root of 72. From there, we find we can pull out it is 36 times square root of 2. But 36 has a perfect root. That's why we have 6 there, and 2 remains there as square root of 2 to qualify the simplification as a surd. We move to 125. The experience of cubes and square roots would show 125 broken up is 25 times 5. So we have root 25, square root 25 times square root of 5. Square root 25 has a perfect root, which is 5. So 5 square root of 5 is the simplified form of that surd. So those are the 3 simplifications. So when you are simplifying lana, always look out inside for the multiples. You are most likely to pull out of that sign a root, a number that would have a perfect root. So with that lana, it will be a good time for you to go and work out this assignment to perfect what we've just done. So lana, that is the assignment. Simplify the following surds. So sorry, this one was supposed to be 40, number 1. Number 2, square root of 162. So square root of 40, square root of 162, square root of 75, square root of 150, square root of 54, square root of 50, square root of, so this is 500 instead, square root of 500, 7, square root of 12, 8, square root of 200, 9, square root of 300, and lastly 10, square root of 98. So work out those assignments to perfect your work on simplification. So thank you very much for the audience, and let's meet well prepared for the next lesson. Bye-bye.
How are you, my learner? Welcome to our lesson today, that is Manifested e-learning platform. My name is Purity Anzelimo, and our subject of our lesson today is physics, and it's a continuation. We'll continue with the topic in Form 4, that is electromagnetic spectrum. That's our topic, electromagnetic spectrum. And in our lesson, during this lesson today, we'll look at numerical calculations involving energy. So we'll be looking at the numerical, or we'll be doing numerical calculations that is involving energy. And by the end of the lesson, you should be in a position to do calculations or get involved in calculation of energy, wavelength, frequency. That is what you should be in a position to by the end of the lesson. So generally or basically, we are going to look at the numerical calculations involving energy, the formula for calculating energy, and also other formulas will follow. Now, before we get to the numerical calculations, just a small recap of the previous lesson. We said that the properties of the electromagnetic waves, one of the properties among the 6 that we mentioned is that electromagnetic waves possess energy in different amounts. That's what we said, that the electromagnetic waves possess energy in different amounts. And something else that we said is that the electromagnetic waves are waves in nature. So they are transverse waves. They are waves in nature. And this way we are going to borrow when we now be calculating in this lesson. So we know that they possess energy in different amounts. They are also waves in nature. And therefore, to start with, I would like us to write the wave equation. Now that these electromagnetic waves are waves in nature, we are going to consider the wave equation. Wave equation derived in Waves 1, Book 2, whereby we say that the speed or the velocity, can first write it in ones. We know that the speed of a wave or the velocity is equal to wavelength multiplied by the frequency. And therefore, the speed, where we use letter V, that is not the speed or simply the velocity, is simply equal to wavelength. The symbol for wavelength is lambda. And the symbol for frequency is small letter f. And therefore, V is equal to lambda f. And this is simply what we refer to as the wave equation, where V is the speed or the velocity of the wave. So V is the velocity or simply the speed of the wave. And the units for velocity is meters per second. Then our lambda, as we have seen, this is the wavelength of the wave, and the units are meters. And then we have frequency, which is in hertz. So that is the wave equation. And in this case, as we'll be talking about the electromagnetic waves, because we also saying that one of the other properties of the EM waves is that they travel with the speed of light. So in this, we can now use C. Instead of V, we'll use C. Letter C represent the speed of light in a vacuum. So we are going to have it as C is equal to wavelength multiplied by the frequency, where we are saying C is simply the speed of light, in vacuum. So that is it. So this is the same wave equation. that we are talking about, the wave equation, but in this case we are using C to represent the speed of light in vacuum. So in these calculations, we'll be taking the value of the speed or the velocity to be the speed of light. So even if you are not given in the question, you may not be given the speed, the value of C, or sometimes it can be V. You may not be given the values, but you should know that we say that all electromagnetic waves will travel with the speed of light, and therefore C will always be 3.0 times 10 power 8 meters per second. So this is our wave equation. That's the wave equation. Then I want us now to derive a formula for calculation of energy. So we are going to use these formulas together. The first one, the wave equation, and then the equation involving energy. As we said, electromagnetic waves possess energy in different amounts. And one thing I would like you to note is that energy is directly proportional to frequency. The more the frequency, or the higher the frequency, the more the energy. So we can say that energy represented by a capital letter E is directly proportional to frequency, represented using a small letter f. And therefore we can write it mathematically, whereby energy is directly proportional to frequency. That is what we have. E is directly proportional to F. So from the knowledge in mathematics, when we want to remove this sign of proportionality, we put an equal to sign and we introduce a constant. So we are going to have E is equal to a constant, which is represented using letter H, and then our frequency. And this H, which is our constant, is simply referred to as the Planck's constant. It is the Planck's constant. We have the Planck's constant, and it is approximately 6.63 times 10 power negative 34 joules second. You don't need to clamp this one. You'll always be given, whenever you are given a question involving you to use the Planck's constant, you'll be given that constant. At times, they also give us 6.64 times 10 power negative 34 joules second. So that is it. So we have energy, therefore, is equals to the Planck's constant multiplied by the frequency. So this is another formula that you need to note, where E is the energy, and energy is in joules. Those are the units for energy. So E is for energy in joules. H, we have seen, is the Planck's constant in joules second. And F from our area definition is the frequency in hertz. So this is another formula that we are also going to use, and we have seen we are getting it from energy is directly proportional to frequency. So when we were looking at the electromagnetic waves, therefore we can say, if I may ask you, which electromagnetic wave has the highest energy? Yes, it is the gamma rays, because gamma rays have the highest frequency, and the more the frequency, the more the energy. And of course now the radio waves will have the smallest energy because their frequency is the lowest. Then we can combine the two formulas and see what we have before we get into the calculations. So we have seen the first one is the wave equation, where C is equal to lambda F, and then we have seen energy is equals to Planck's constant multiplied by the frequency. Now using this equation, we can make frequency the subject of the formula. So we are having E is equals to HF. So if we make F the subject of the formula, meaning that we divide both signs by H, we'll end up getting that our frequency is equal to E all over H. That is what we have. And therefore, we can come up with another formula where we have F, we substitute with E over H, meaning that the speed of light will therefore be equal to our wavelength multiplied by the frequency, which is E all over the Planck's constant. That's another formula. And finally, we can derive another one from this, whereby we are saying that our speed is equals to wavelength multiplied by frequency. We also have that energy is Planck's constant times frequency. Now, using the first equation, we can make frequency again the subject of the formula, whereby we have C equal to lambda F. So when we want to make F the subject, we can divide both signs by lambda. So we end up getting that frequency is the speed of light divided by the wavelength. So where we have F in our second equation, again we can substitute with C all over lambda. So we are going to have E is equals to Planck's constant multiplied by the speed of light divided by the wavelength. So provided you have the two formulas, these two formulas here, provided you have this one and this one, you can be able to get any other formula from the two. So from this, we can be able to get the wavelength of an electromagnetic wave, frequency. We can also be able to calculate the energy, and we can also be given all the others, and we are told to calculate the Planck's constant. So I want us to get into questions. So that is it. Those are the formulas that we are going to use. The wave formula, which is this one, and also the formula relating energy and frequency, which is E is equal to Planck's constant multiplied by the frequency. And always ensure when you are doing any calculations involving this, ensure that every quantity is in its SI unit. So if, for example, you are given frequency in megahertz, always ensure that you first convert into hertz. If you are given, for example, the wavelength in kilometers, always ensure that you convert it into meters. So you shouldn't be in a position, if you are given energy, for example, in kilojoules, convert it into joules. So calculations should be done when the quantities are in their respective SI units. So I want us to back into a question and see whether we can be able to apply the formulas that we have been able to derive. So some examples. So example number 1, we have the following question. We have green light has a wavelength of 5 multiplied by 10 power -7 meters. That is the wavelength. You are told to calculate the energy it emits. Calculate the energy it emits. And you have been given the value of H to be 6.63 times 10 power -34 joules second. So that's one of the questions that you can be given, a very simple question here. Green light has a wavelength of 5 times 10 power -7 meters. Calculate the energy it emits. And the Planck's constant is given as 6.63 times 10 power -34 joules second. So whenever you are given a question in physics involving calculation, it is always good to first analyze, state what is given, and then what is in question, and see the formula that you need to apply. So here we have been given the wavelength, So wavelength we have as 5 times 10 power negative 7 meters. Then we also have the Planck's constant, which is 6.63 times 10 power negative 34 joules/second. Now, from this, what else do you think we have been given, though it may not be written here? What else do we know? Now, we are talking of green light. Green light is an electromagnetic wave because it is in that group of the visible light. And therefore, the speed of the green light is the speed of light. And therefore, we have C, which is 3.0 times 10 power 8 meters per second. So you may not be given the value here, but you know that green light is an electromagnetic wave, and electromagnetic waves travel at the speed of light, which is 3 times 10 power 8 meters per second. And therefore, we are told to calculate its energy. So we are calculating the energy. So we can come to the formulas that we have and see which one we are going to apply. So we have this energy, Planck's constant, we have the speed of light, and we have the wavelength. So we can apply that formula. So we get the energy it will emit. So energy is equal to the Planck's constant multiplied by the speed of light divided by the wavelength. So that is what we have. So that formula has all the quantities that we have here. So our energy will therefore be Planck's constant, which is 6.63 times 10 power negative 34 joules/second, multiplied by the speed of light, which is 3.0 times 10 power 8 meters per second, divided by our wavelength. And our wavelength is 5 times 10 power negative 7 meters. So that is what we have in the question. And we want to be able now to calculate the energy. So we are going to find what we have in our calculators. You find what we have in the calculators. This is what we have. And you can see what is going to happen to the units so that we can get the units for energy. Because you can see here we have joules/second. We are multiplying by meters per second. Meters per second simply means is like we are dividing. Therefore, meaning that this and this will cancel. So in the numerator, we remain with joules, meters. Then in the denominator, we have meters. Meters and meters will cancel. And therefore, our answer will be in joules. So you can feed it in your calculator and get the answer. So we have 6.63 multiplied by 10 raised to power negative 34. Then you are multiplying by 3 multiplied by 10 power 8. Then divide by 5 multiplied by 10. 5 multiplied by 10 power negative 7. So what do you end up getting as the final answer? You end up getting 3.978 multiplied by 10 raised to power negative 19. And as we have said, it is in joules. So that is what we have for that. That is the energy. We have said is Planck's constant multiplied by the speed of light divided by the wavelength. And you can see this and this will cancel. We remain with joules, meters, divided by meters, we remain with joules. And that is the SI unit of energy. Hopes that is clear. So we want to look at another example. So example 2. Question number 2. And remember, when you are feeding this in your calculator, it's always good that you remember to put the bracket. You just open the bracket, you write this, close it, you multiply, open it again, write this, you close it, you get the answer. You can write it first as the numerator, or you can just leave it in your calculator. Then you divide by, open the bracket again, 5 times 10 power negative 7, close it, and then the equal to sign. You'll be able to get 3.978 times 10 power negative 19 joules. So question number 2, or example number 2, a radio station is transmitting at a frequency, a radio station. So we have a radio station is transmitting at a frequency of 15.42 megahertz. So we are told to calculate the wavelength, of the transmission. Calculate the wavelength of the transmission. So that is what we have as our question. We are told that a radio station is transmitting at a frequency of 15.42 megahertz. Calculate the wavelength of the transmission. Calculate the wavelength of the transmission. So again, we analyze that question. What are we given and what is in question? So we have a frequency. The frequency given as 15.42 megahertz. Then what else are we given in the question? We have been given the frequency, but we know since these are radio station, it is transmitting radio waves. And radio waves are electromagnetic waves, and therefore they travel with the speed of light, which is 3.0 times 10 power 8 meters per second. So we want to calculate now the wavelength. So that is what is in question. Remember, before we calculate, we ensure that every quantity is in its SI unit. Here we have frequency in megahertz. We know that 1,000,000 hertz make 1 megahertz. 1,000,000 hertz, this 1,000,000 is equivalent to 1 megahertz. So what about 15.42 megahertz? So we need to convert this in hertz, which is the SI unit of frequency. So we have 1,000,000 multiplied by 15.42 divided by 1. So we have 15.42 multiplied by 1,000,000 all over 1. So we end up getting this as 1542. So that will be 15,420,000 hertz. So that is the frequency that we are going to use. So we now come and look at the formulas that we derived. Which formula are we going to apply to get the wavelength? The formula that relates frequency, the speed, and the wavelength. And that is simply the wave equation. So we just come and note down the wave equation. The wave equation. And we say that wave equation C is equal to wavelength multiplied by frequency. So that's what we have. In our question, we want to get the wavelength. We can make it the subject of the formula, or simply we can just substitute what we have and finally get the wavelength. So we have our C as 3.0 times 10 power 8 meters per second is equal to wavelength, which is in question, multiplied by the frequency, and the frequency is 15,420,000 hertz. So that is what we have. These are hertz. So we want to get the value of lambda, which is the wavelength. So we have 3.0 times 10 power 8 being equal to, now when we multiply, we are going to have 15,420,000 15,420,000 multiplied by lambda. So it is 15,420,000 hertz. We want to get the value of lambda, not hertz only, but multiplied by lambda. So we want to get the value of lambda, and therefore we can divide both signs by 15,420,000 on both sides, 15,420,000. So of course this and this will be 1, so it cancels. So we remain with this. So our lambda will be 3 times 10 power 8 divided by 15,420,000. So again, you just pick your calculator and we find this. So we have 3. Remember to put the bracket. You first open the bracket, put 3.0 times 10 power 8. Cross it, then divide by, open again, 15,420,000. Close the bracket and get an equal to sign. And you'll now be able to get the answer. We can give our answer correct to 2 decimal places. 2 decimal places. So you first get to 3 decimal places. We have 19.455. We can round off now to get to 2 decimal places, and we get that our lambda is 19.46 meters. Those are the units for wavelength. So our wavelength is 19.46 meters. And that is now the wavelength of the transmission for those radio waves. So we have 19.46 meters. Hopes it's clear. So once you are given a question, analyze it, get what is in question, and then using the formula, see which formula will apply. Like in this, we could not use the formula for energy because this question is not asking anything to do with energy, neither are we given the energy. So analyze it, then get to know what is in question. So I would like us to do another example, example 3. Example 3. Question 3, we have the following. We have the following question for, we are told that a radio is tuned into a radio station 144 kilometers away. 144 kilometers away. So the radio is 144 kilometers away from a radio station. So the first question is, how long does it take a signal to reach the receiver? So that's the first part of that question. A radio is tuned into a radio station 144 kilometers away. So here we are having a radio which is being tuned, and it is away from the radio station that is 144 kilometers away. So in this radio station, this is where the radio waves are produced. They are being transmitted, then they are received in the receiver, that's in the radio. So we are asked, how long does it take a signal to reach the receiver? So in this question, we have the distance. In this question, we have the distance that is covered by that radio wave, which is 144 kilometers. So we want to get the time it takes to get to the receiver. And we know that since this is a radio wave, again, so the speed of that radio wave will be the speed of light, which is, so we have the speed of light, which is 3.0 times 10 power 8 meters per second. So we want to know what's the time taken. So how long does it take a signal to reach the receiver? And we know from the knowledge in mathematics and also in physics, we know that speed is given by, speed is distance over time. So we have our speed, and this is not the speed of light, which is the speed of the radio wave. So we know that speed is equal to distance all over time. And our speed is 3.0 times 10 power 8 meters per second. Is equal to distance. Our distance is 144 kilometers. And we want to know the time that will be taken. And since here we have kilometers, here we have meters, we need to convert this distance in meters. So we convert the kilometers in meters. We know very well that 1,000 meters make 1 kilometer. So when we have 144 kilometers, simply multiply by 1,000 to get 144,000 meters. So we have 3.0 times 10 power 8 meters per second is equal to 144,000 meters all over the time taken. So we want to get the value of time. So we have 3.0 times 10 power 8 meters per second equal to 144,000 meters all over time. So we come and cross multiply. So we are going to have 3.0 times 10 power 8 meters per second multiplied by time equal to 144,000 meters. So remember, we still want to get the value of t, which is the time taken, or want to know how long it takes the signal to reach the receiver. So we have 3.0 times 10 power 8 meters per second times time equal to 144,000 meters. So to make t the sum check, we divide both signs by 3.0 times 10 power 8 meters per second. This sign we have 3.0 times 10 power 8 meters per second. So of course this is going to cancel. Then now we can divide this using our calculators. So you just pick your calculator and divide. We have 144,000 divided by, sure you open the bracket, 3 times 10 power 8. So what do you end up getting? So we end up getting that our t, which is now the time, is 4.8 multiplied by 10 raised to power negative 4. This is time, and the meters is going to cancel. So we have seconds. Just a very short time, a very short time. It takes a very short time. 4.8 times 10 power negative 4 seconds. That is for the signal to get to the receiver from a radio station which is 144 kilometers away. So that's what we have as the time that will be taken. So speed, distance over time, we have the speed, that is the speed of light because it is a radio wave which is an EM wave, and we have the distance in kilometers. We've converted into meters, which is the SI unit, and then we are able to get the time. So part B of that question, we have part B of the question. So we have answered the first part. So part B of the question, part B, we are told that if the signal has a frequency, of 980 kilohertz, how many wavelengths is the station away from your receiver or from the receiver? So in part B, we are told that if the signal has a frequency of 980 kilohertz, how many wavelengths is the station away from the receiver? So again, in this question, we've been given the frequency, which is 980 kilohertz. We've also been have now been told to calculate the wavelength. How many wavelengths? So the wavelength is in question. But remember again, because it is a radio wave, the speed will be 3.0 times 10 power 8 meters per second. So that is what we have. We want to calculate the wavelength. We have the frequency and we have the speed. And we know that this frequency must be expressed in its SI unit, which is hertz. So we start by converting. We convert the kilohertz into hertz. 1,000 hertz make 1 kilohertz. So we have that 1,000. We can convert so that now we get the number of wavelengths. 1,000 hertz make 1 kilohertz. And here we have 980 kilohertz. So how many hertz are those? We cross multiply, we end up getting 980 multiplied by 1,000 over 1, which will simply be 980,000 hertz. So that's what we have. We have frequency, we want wavelength, we have the speed. So again here, as you can see, we apply the wave formula or the wave equation. And the wave equation is C is equal to wavelength multiplied by the frequency. Our C is 3.0 times 10 power 8 is equal to our wavelength, which is in question, multiplied by the frequency, which is 980,000 hertz. So again, we make wavelength the subject. So we have 3.0 times 10 power 8 equal to 980,000 multiplied by lambda. So to get lambda, we divide both sides by 980,000. 980,000. So this will cancel. So we end up getting our lambda, which is the number now of wavelengths, as we have the following as the wavelength. We can now divide using our calculator. 3.0 multiplied by 10 power 8. Then divided by, open the bracket, we have 980,000. So we end up getting the wavelength, or the number of wavelengths. We have the wavelengths as 306. We can write to 2 decimal places, 0.12 meters. So that is the wavelength. We have 306.12. 306.12 meters. So that is the wavelength. That's what we are asked in this question. Of course, we have been able to analyze. The time you analyze the question, you can see it clearly. So you'll be able to see which equation or which formula are you going to apply. So in this, it is very clear that we can apply the wave equation and we are able to get the value of wavelength as 306.12 meters. So that is it. I'd like to give you one question that you can try work it out. So you are given the following, an exercise for you here. So you are given the following. You are told that an X-ray machine produces radiation of wavelength 1.0 times 10 power negative 11 meters. An X-ray machine produces radiation of wavelength of 1.0 times 10 power negative 11 meters. Full stop. Calculate A, the frequency of the radiation. The frequency of the radiation. And number 2, its energy content. Number 2, its energy content. And in this question, you have been given the value of H, which is the Planck's constant, as 6.63 times 10 power negative 34 joules second. H is 6.63 times 10 power negative 34 joules second. So you should work that one out. And lastly, also calculate this. You've been given the following. Calculate, question number 2, calculate the wavelength of green light. Calculate the wavelength of green light of frequency. Calculate the wavelength of green light of frequency 5.0 times 10 power 14 hertz. Of frequency 5.0 times 10 power 14 hertz in air. Calculate the wavelength of green light of frequency 5.0 times 10 power 14 hertz in air. So you can do those calculations. And as we have seen, always remember the formulas. The two major formulas that we have been able to come up with. Number 1 is the one relating energy and frequency. And we have seen that energy is equal to Planck's constant multiplied by frequency. So note that. And number 2 is the wave equation. C is equal to lambda multiplied by the frequency. And when you have these two, you can now be able to calculate any quantity that you can be given. So that is it on calculations. Continue doing more and more to practice on the calculations involving energy and the wave equation. And therefore, since we have covered that, during the next lesson, we'll now be looking at now these electromagnetic waves. How are they produced? How are they detected? And what are their uses? Thank you for following.
Welcome again, learners. As I promised in our last lesson, I'm going to proceed in this lesson with an example on how to calculate quartiles. That is upper quartile, second quartile, and third quartile. So allow me to rub here. I'm going to write the example on the board here. Then we will work out the example. Let me write my example here on the board. Example. The table below, let me just do away this, away with that. This is an example. Example. The table below shows the distribution of heights, to the nearest centimeter of 40 students. So we have height in centimeters, 145 to 149, 150 to 154, 155 to 159, 160 to 164, 165 to 169, 170 to 174, 175 to 179. Then we have the frequency. Frequency, 5 students, 16 students, 9 students, 5 students, 2 students, and 1 student. So that is the distribution. That is the distribution. Let me use my blue pen. My blue, 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 blue. This is example. The table below shows the distribution of heights to the nearest centimeter of 40 students. So we have centimeters in groups of 145 to 149, 150 to 154, 155 to 159, 160 to 164, 165 centimeters to 169 centimeters, 170 centimeters to 174 centimeters, 175 centimeters to 179 centimeters. That means that between 145 to 149 centimeters, there are two students that whose height is falling within that category, that group. Then 5 students' height is between 150 centimeters and 154 centimeters. 16 students measure 155 to 159 centimeters. 9 students measure between 160 centimeters to 164 centimeters. 5 students' height is between 165 centimeters and 169 centimeters. Then 2 students' height lies between 170 centimeters and 174 centimeters. And lastly, 1 student's height is between 175 to 179 centimeters. So what are we required to calculate? We are required to calculate the median first. Calculate A, median, B, lower quartile, and C, upper quartile. Upper quartile. That is the question. Let's have the answer. You are going to answer this question. Answer. So first we'll have the height, one column. We are going to put this data into columns, 2 columns. We have 145 to 149, 150 to 154, 155 to 159, 160 to 164, 165 to 169, 170 to 174, 175 to 179. Then frequency we have 2, 5, 16, 9, 5, 2 and 1. 2 and 1. So learners, in calculating the median, we require, from this formula, we require the lower class boundary, we require the total frequency from this formula. We are going to need also the cumulative frequency, the frequency and the class interval. The cumulative frequency. So let us first cumulate. This is cumulative frequency. The cumulative frequency, we have 2 plus 5, 7, 7 plus 16, 23, 23 plus 9, 32, 32 plus 5, 37, 37 plus 2, 39, 39 plus 1, 40. And we saw that the total number of students are 40. So this is the total frequency is 40. So median, let's first calculate median. Median, A, median. We have seen that median is equal to lower class boundary plus 1 over 2 n, a half n, okay, minus c over f times the class interval, So this will be equal to, so learners, the first calculation we need to do is to get the a half item, which is equal to a half times 40, that is the 20th student. That is the 20th student. The 20th student lies, the 20th student, because this is a half of 40. A half of 40 will give us the 20th student. The 20th student. So we need to find out where does the 20th student fall. The 20th student falls in this class, because falls in this class, sorry, supposed to be this class. The 20th student falls in the class where we have 23 cumulatively. That is 155 to 159. Okay, this class 155 to 159, this class is where the 20th students lie, because the 20th student cannot lie here in this class or here. 20th student is within this cumulative class of 155 to 159. So the cumulative, the median class in this case now becomes the median class. Median class is 155 to 159. 155 to 159, this is the median class. That is step number 1. You calculate get half of the total frequency. That will help you identify the median class, because we need this median class to be able to determine the lower class boundary of the median class. L is the lower class boundary of the median class. So what is the class boundary here? This is class limit. We need to calculate class boundary. Class boundary, we simply, the lower class boundary, we simply deduct 0.5 from 155, and this will be equal to 154.5. We deduct 0.5 from 155, that will give us 154.5. So the lower class boundary is equal to 154.5. 154.5, then we add, going to add a half of n, which we saw is 20. So we have 20 minus the cumulative frequency above the median class. If this is the median class, then the cumulative frequency above it will be 7. So 7 is the cumulative frequency above this median class. So the cumulative frequency above the median class is equal to 7. Then we get the frequency of the median class. The frequency of the median class, this frequency here is 16. Frequency of the median class is equal to 16. What else? We need to calculate to determine the class interval of the median class. Class interval of the median class. So learners, we are going to get the class interval of the median class. Remember here we used the class boundary. We have the lower class boundary. We need to determine the upper class boundary. The upper class boundary, then getting the difference, we'll have the class interval. So here we have this 159, we'll add 159.5. The lower class limit, we deduct 0.5. The upper class limit, we add 0.5, giving us 154.5. That is 155 minus 0.5 will give us 154.5. Then on the upper class limit, we add 0.5 to get 159.5. So to calculate the class interval, we get the difference between 159.5 and 154.5. 159.5 minus 154.5, which is equal to 5. So 5 here is the class interval. 5 is the class interval. Now the rest, learners, is the work of the machine. Okay, we will use the machine here. That is 20 minus 7 divided by 16 times 5 plus 154.5. This is equal to 158.563 is the median. That is the median, 158.563. How about the lower quartile? Let's calculate the lower quartile, B, the lower quartile Q1. Q1, what's the formula? The formula is L plus 1 over 4n minus C over F times I, where L is the lower class boundary of the first quartile, plus then n is the total frequency, C is the cumulative frequency above the first quartile class, F is the frequency of the first quartile class, I is the class interval, the class interval. So first we need to determine 1 over 4 times n, which is equal to 1 over 4 times 40, which is equal to 10. 4 goes here once, 4 goes here 10 times. So the 10th item, or the 10th student, where does the 10th student lie in this cumulative frequency? The 10th student will lie in this class of 155 to 159. So the first quartile class is 155 to 159. That is the first quartile class, the lower quartile class, 155 to 159. This will now help us calculate the cumulative frequency. So, and also the lower class boundary. The lower class boundary here will be 154.5, just like the other case, 154.5 plus 10, a half of n is 10, minus cumulative frequency above the first quartile class. The cumulative frequency here is 7, okay, over frequency of first quartile class, frequency of the first quartile class, this is first quartile class, is equal to 16. So I'll have 16 there. Then we multiply by the class interval. The class interval here, learners, is going to be 154.5 to 159.5. The difference between 159.5 and 154.5 is equal to 5. So the rest is the work of the machine. The machine will give us the answer here. So we'll have 10 minus 7 divided by 16 times 5 plus 154. So the answer here is 155.437. That is the lower quartile. Lower quartile. Let's move on to the upper quartile. The upper quartile candidates. The upper, this is C, you're answering C. C, the upper quartile, Q3, is equal to the lower class boundary plus 3 over 4n minus C over F times I. So first we'll calculate the 3 over 4 times 40, which is equal to 30. So the 30th student, where does the 30th student lie? This will help us get the third quartile class. 30th student will lie here. So the 30th, the third quartile class will be 160 to 164. 160 to 164. Therefore, the boundary will be 160. The lower class boundary 160 minus 0.5 is equal to 159.5. The upper will be 164.5. So I'll come here and insert the values. We have 159.5 plus 3 over 4 times n is equal to 30 minus cumulative frequency above the third quartile class. Cumulative frequency above this class is equal to 23. Come here and write 23 divided by the frequency of the third quartile class. The frequency of the third quartile class is equal to 9. All right. Come here and write 9. Then times the interval. The class interval will be the difference between these two, which is equal to 5. So the rest, the machine. Okay. Work of the machine. This will be equal to 30 divided by 23 minus 23 divided by 9 times 5 plus 159.5. So the answer here is 163.388. That is the upper quartile. The upper quartile. So we have calculated the upper quartile, learners, and that will mark the end of our today's lesson. We'll mark the end of our today's lesson. But I'm looking for your assignment, learners. I want you to go and have this assignment done. Assignment. The exercise is 2.2. Go and do question 1, question 2, question 3, question 4, question 1 up to question 4. Question 1 up to question 4. Go and attempt. This one is requiring median and quartiles, median, lower and upper quartiles. So that is your assignment. This is students book 4. Go and do exercise 2.2, question 1 up to 4 only. Thank you for attending. I hope to meet you in our next class.
Bye-bye.
Welcome to our physics lesson today. My name is Purity Anzelimo. You are teacher of physics. In our lesson today, we continue with the cathode rays and the cathode ray tube. That's our topic. Cathode rays and the cathode ray tube. During our previous lesson, we have been looking at the parts of a cathode ray oscilloscope, and we were able to know that a cathode ray oscilloscope is used in the production of cathode rays, and we were able to see the three major parts of a cathode ray oscilloscope, namely the electron gun. We also have the deflecting system and also the screen or the display system. So those were the major parts, or those are the major parts of a CRO. In the electron gun, we have the cathode, that is the heated cathode, the ground, and the anodes. In the deflecting system, we have the X plates and the Y plates. And in the display system, we have the screen. So during our lesson today, we continue with the cathode ray oscilloscope, but now we want to look at the uses of a CRO. So uses of a CRO, uses of a cathode ray oscilloscope. And we are going to look at two major uses of a cathode ray oscilloscope. We are going to explain each one of them. So one of the uses of a cathode ray oscilloscope is used as a voltmeter. So number one, used as a voltmeter. A cathode ray oscilloscope is used as a voltmeter. We know from the topic current electricity, we know that a voltmeter is a device that is used to measure voltage. So we have the CRO being used to measure voltage. So we are going to explain how. Then again, we can use a CRO to determine the frequency of an alternating current signal, used in determining the frequency of an alternating current signal. So we will also explain how a CRO can be used to determine the frequency. Remember, we know what frequency means. When we talk of frequency, simply refers to the number of complete oscillations in 1 second. So it can also be used in determining the frequency of an alternating current signal. So I want us to start with the first one. We have seen that a cathode ray oscilloscope can be used as a voltmeter. So CRO is a voltmeter. Our CRO as a voltmeter. And we are going to see that the cathode ray oscilloscope will have many advantages over the voltmeters that we use, the ordinary voltmeters that we have. So when we are using the cathode ray oscilloscope as a voltmeter, when the timepiece is switched off, with the timepiece switched off, when we have our timepiece switched off, then we also have the X plates being earthed, X plates earthed, and then we have the voltage to be measured, connected, and voltage to be measured, connected to the Y plates. So this is what we are going to have. So when we have the timepiece switched off, remember we said that the timepiece is connected to the X plates, and now we want to, and the X plates are earthed, and then we have the voltage to be measured, connected to the Y plates. Then we are going to have that the voltage, these are the Y plates. Remember we said there are two. So the voltage will be given by the displacement multiplied by the sensitivity. And in the sensitivity, that is simply the volts per division. Sensitivity is simply the volts per division. So when we have the time base switched off, the X plates at and the voltage to be measured connected to the Y plates, then we can calculate the voltage as displacement. Remember, we said that in the deflecting system, we have these Y plates which are responsible for the vertical deflection. And that's why we are talking of the displacement. We are going to apply this in our numerical calculations. So voltage will be given by the displacement multiplied by the volts per division. And in this volts per division is also referred to as the sensitivity. So that's how we can use a CRO to calculate the voltage, or that's how a CRO can be used as a voltmeter, and we are going to employ this in our calculations. So note voltage is equal to displacement multiplied by the volts per division. And as I've said, a voltmeter is a device that is used to measure voltage. And therefore we have our other voltmeters, the ordinary voltmeters. But now we are saying that the CRO is advantageous or has more advantages over the ordinary voltmeter. And we look at those advantages. So we look at advantages of the CRO over the voltmeter. Advantages of the CRO over the ordinary voltmeter. Now, a CRO as a voltmeter, we have seen that it can be used as a voltmeter. What are the advantages of the CRO when used as a voltmeter over the ordinary meters? So one of the advantages is that it can be used to measure both direct current and alternating current voltages. That's number one. Remember, for the voltmeters that we have or that we use in the lab mostly, they are only used to measure direct current voltages. So but for the CRO can be used or can measure both the direct current and the alternating current voltages. So that's one of the advantages of a CRO over the voltmeter. Then we can also say that it can also be used to measure large currents. It can be used to measure large, not currents, but voltages, because it's used as a voltmeter. It can be used to measure large voltages without being destroyed. We know in the voltmeters that we use in the laboratory, most of them ranges from 0 to 5 volts, others from 0 to 3 volts. But now for the CRO, it can be used to measure larger voltages. So can measure larger voltages compared to the ordinary voltmeters. So it can be used to measure larger voltages compared to the ordinary meters, and it cannot be destroyed. So without being destroyed. That is another advantage of a CRO over the ordinary voltmeters. Then we know very well when we are using the voltmeters, that is in electricity, when we use the voltmeter, when you want to read the screen or the reading, we usually check where the pointer, how the pointer moves. If, for example, this is my pointer, these are the readings here on the voltmeter. We know very well that this pointer, when you want to get the reading, it swings fast. It swings around the reading. It swings and then it points where the reading is to be. And the reason as to why it swings before getting to the point where the reading is due to inertia. Due to inertia, which we discussed also in the Newton's laws of motion. So as a result of inertia, then this pointer will swing momentarily about the point or the actual reading. But for a CRO, it's not affected by inertia. And therefore the reading will just be read directly instead of the pointer having to swing about the point where the reading is to be taken. So that is another advantage of a CRO. So we can say that it responds at an instant or instantaneously responds instantaneously. The response instantaneously, unlike the ordinary meters which swing, or which, unlike the ordinary meters, we can talk of whose pointers are affected by inertia. So they will sing about the point and before they show the actual reading. But now for a CRO, it will respond instantaneously, unlike the ordinary meters, which we are saying the pointers are affected by inertia. Then we can also say that with the CRO, another advantage over the ordinary meters, another advantage, number 4, we can say that the CRO has a very high resistance. It has an infinite resistance, and therefore it does not take any current. It has very high resistance, any current. It has a high resistance, hence does not take any current. From current electricity, that is on Ohm's law, we know very well that Ohm's law relates voltage to resistance, that is V is equals to IR, and we are saying that a CRO has a very high resistance. This is very high for a CRO, and that means when it is high, it is not going to take any current or even any voltage. The voltage and the current are not going to be affected when the value of the resistance is high, because from this we know that the current will be equal to V all over R, and we are saying that when this is very high, then it's not going to affect this current. It's not going to take any current, because if it were low, it means that then this will be affected. The current will be affected for us to get the voltage, because it's being used to measure the voltage. So it has a high resistance, or what we are calling infinite resistance, and therefore it does not take away any current. So those are the uses of a CRO. That the first use, which we have just discussed, that it is used as a voltmeter, and we are saying that when the time base is switched off and the X plates are at, the voltage can therefore be measured, or can be measured while connected to the Y plate. And voltage, we have seen, will be given by the displacement multiplied by the volts per division. And then we have also explained why the CRO is preferred to the ordinary voltmeters. It has the following advantages. We have mentioned 4 of them. It can measure both direct current and alternating current voltages, unlike the voltmeter, which only measures the direct current voltage. Then it can measure larger voltages compared to the ordinary voltimeters without being destroyed. We have also seen that it is not affected by inertia, so it can respond instantaneously, unlike the other meters. Then we've also seen that it has infinite resistance, and hence it does not take any current away. So we want to look at the other use of a CRO, use number 2, where we have seen that it is used in determining the frequency of an alternating current signal. So used to determine the frequency, CRO to determine the frequency, used in determining frequency that is of an alternating current signal. And in this one, the signal is fed into the Y plates. The signal is fed into the Y plates. The signal is fed into the Y plates with the time base on. The time base is on, with the time base on, and we are saying that the time base control is then adjusted. The time base is controlled. The time base can be controlled. The time base control, is adjusted to give one. It is adjusted. The time base control is adjusted. So this time base, remember, it is on the X plate, is adjusted to give many cycles as possible. It is adjusted to give more cycles, So remember, in this, we are going to have the formation of the cycles. We can have it here. So there will be formation of the cycles. So we can have this. That's what we are going to have. So we are saying that when the time base is on, and this time base control is adjusted to give more cycles, and therefore from this, then we can say that when we want to calculate the frequency, the periodic time is recorded. The time, or what we call the periodic time is the time taken to complete one cycle. This time which is taken to complete this cycle, the time which is there, is what we are calling now periodic time, represented using a capital letter T. And we can say that the periodic time is determined. It is determined by relating the trace of the signal by relating the trace of the signal on the screen with the time base setting. So the periodic time is now being determined by relating the trace of the signal, which you have seen, the trace of the signal on the screen, with the time base setting. So we can be able now to get the periodic time, because we are saying that the time base is on. So when we get the periodic time, then we can now be able to calculate the frequency F, by the formula. Frequency is simply the reciprocal of the periodic time. of the periodic time t. And therefore, we can be able to calculate frequency by getting the reciprocal of the periodic time. So that's how we can use a CRO to determine the frequency of an alternating current signal. Because when we get the periodic time from the connections whereby we are saying the signal is fed into the Y plates, then the time base is on, the time base control is adjusted to give cycles many as possible, and therefore the periodic time is determined by relating the trace of the signal, this is the signal on the screen, with the time base setting. So with this, we can be able to get the periodic time and hence able to calculate the frequency. So the frequency will be the reciprocal of the periodic time. So those are the two uses of a CRO. One used as a voltmeter, and we have seen that the voltage here will be given by the displacement multiplied by the divisions, that is the sensitivity. And then we have also seen that it is used in determining the frequency of an alternating current signal. So those are the two uses, and you should be able to explain how it is used. In this, we are going to do more calculations. We'll apply this formula in our calculations. We'll also apply the formula on calculation of voltage, which we have seen being given by displacement multiplied by the sensitivity. So we want now to compare a cathode ray oscilloscope to a TV tube. We want to look at the differences that are there between a cathode ray oscilloscope and the TV tube. So we look at those differences. So differences between a CRO and a television tube. So what are the differences between the two? Differences between a cathode ray oscilloscope and a TV tube. So we can just have a table. On one side we can have the TV tube, and on the other side we have the CRO. So this is our TV tube. Then on the other side we have the CRO. So we want to see what are the differences between a cathode ray oscilloscope and a television tube. So one of the differences for a television tube, the deflection here, the deflection is by magnetic field. Whereas in a CRO, the deflection is by electric field. So you need to know that in a TV tube, the deflection is by the magnetic field, whereas in a CRO, it's by the electric field. Then a TV tube has two time base. It has two time base. Whereas in a CRO, as we mentioned, it has only one. Has one time base, which we said it's on the X plates. Then we can also say that electrons light the whole screen for a TV tube, and that's why you are able to see the whole screen being lit in a TV. So the electrons light the whole screen. The whole screen. Whereas in a CRO, as we said, the electrons will only form a spot. Electrons form a spot on the screen. This we were able to explain. So the electrons which are being produced in a cathode ray oscilloscope will only form a spot on the screen. Unlike in a TV tube, where the electrons will light the whole screen. Finally, there are 625 lines per second in a TV tube. There are 625 lines per second in the TV tube, whereas in a CRO, there are only 25 lines per second. So those are the differences, 4 differences between a TV tube and a CRO. In a TV tube, the deflection is by the magnetic field, and that's why the TV screen is larger than a CRO screen. Then we are saying that a TV tube has 2 time base, whereas a CRO has only 1. In a TV tube, electrons light the whole screen. In a CRO, electrons form a spot on the screen. In a TV tube, there are 625 lines per second, whereas in a CRO, there are only 25 lines per second. So that is it on the CRO, or the cathode ray oscilloscope. In the other lesson, which now will mark the end of this topic, we'll now be looking at the calculations involving the CRO. Now that we have seen we can be able to calculate the voltage, we can be able to calculate the frequency, we can be able to calculate the sensitivity. So that's what we'll engage in. So I'd like to give you some exercise on what we have just covered on the uses of a CRO. So an assignment here for you. Answer the following. So that is the exercise. So we are told in question number 1, state one difference between the deflection systems of a cathode ray tube and the TV tube, which we have just explained. Then number 2, the beam of electrons is subjected to a strong magnetic field which is perpendicular to the path and into the paper. Sketch on the same diagram or on the same figure the new path of the electron. Then number 3, when using the cathode ray oscilloscope to display waveforms of voltages, state where the following should be connected. 1, the voltage to be displayed on the screen. And number 2, the time-based voltage. So that's the exercise. It's good that you answer those questions. And during the next lesson, we'll now look at the numerical calculations involving the cathode ray oscilloscope. Thank you.
Hello, learner. Welcome again to Manifested e-learning platform. We are yet again going to continue with our topic on 3-dimensional geometry. And today our lesson will be angle between 2 planes. So the lesson. And as usual, our lesson should have an objective. So at the end of this lesson, the learner should be able to identify an angle between any 2 given planes and also calculate it. So we have our objective. So the learner should be able to identify the angle between 2 planes and also calculate it. Take, for example, a classroom. It has a floor and the 4 walls. The 4 walls act like 4 planes, plus an additional plane, which is the floor. or if it is you look at it carefully, the planes meet at 90 degrees, but not all planes will be meeting at 90 degrees. You might find some meeting at an obtuse angle or acute angle. So if we take let us look on the board. We have plane A, B, C, D and C, D, E, F. Plane A, B, C, D and C, D, E, F. Initially, we found that if we have a line and you sweep it through a fixed distance, you get a plane. The same for the other plane. Have a line and sweep it, you get a definite plane. So usually if you consider that the plane, a line, a plane is just a composition of many lines, and actually the line was moved at 90 degrees. The line, the planes, the line taken on the plane should be perpendicular to the edge of that plane. So if you look at that angle theta and angle theta. So if you look at our diagram, the angle between plane CDAB and CDEF is theta. The angle between those two planes is theta. There is something you identify. The angle is actually got by taking a line perpendicular to the edge of the other plane. A line perpendicular to the edge of that plane. In the other plane, you take a line perpendicular to the edges of the plane. That is where you fix the angle. So this angle will also be equal to theta. So there is something you notice. The line that is very important. You should notice that. So we shall go straight to an example, a very good example. We call it example 4. So there is a figure there, represents a cuboid. You can try to shade that in the figure. So you realize in the question, it stimulates you to first of all getting a line. When you get a line on a plane with the other plane, it's just the same as the angle between the line, the plane where the line is and the other plane. So we shall go to our diagram. In the figure, N and M are the midpoints of BF and CG respectively. So you are told, find the angle between, we come to A, solutions. We have A, find the angle between BD and BCGF. BCGF. So they're talking of BD. So this is E. They are talking of BD and BCGF. Where is BD? So you have to get, my D is here. BD. So when you are told that, you should trace that line BD. BD. BD and BCGF. So if you look well, there are two angles there. You can either have this angle or the other angle at the end of the other face. So that angle, this is the first angle. In A, you'll get which angle? You'll get angle DBC, angle DBC, or you can still get another angle at the end there, HFG, HFG, HFG. We come to B, AC, AC and plane ABFE. AC and plane, you look at this, AC and plane ABEF, ABFE, ABFE. So you look at AC, AC and this plane, AB and ABEF. So you look at this angle and that plane. So you find it is angle CAB. CAB, or it can be at this edge, this one, or the other angle, GEF. So we move to the third one, C. EM, we look where EM is. EM, EM, EM and plane DHGC, DHGC, DM, EM. So they are looking at these. So you look at that angle. So what you need to do, the way that angle is moving, you'll be forced also to slant this, because it will be at that plane. So you'll be looking at that angle. That angle. So they're talking of the angle between EM and plane DHGC. So you look at angle EMG. 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 Note that carefully. You join M to where this plane is. So where M is, it will take a straight point in the plane. So it will be angle MEG. It will be angle, so sorry, it will be angle GEM. GEM. Lastly, MD. Lastly, MD and ADHE. MD, MD, MD and ADHE. ADHE. So they are looking ADHE. So they are looking at this angle. MD, they'll be looking at this angle. It will be angle MDH. Angle MDH. It can also be the same angle as NAE. NAE. Or angle MNE. So having looked at that, we shall look at a numerical example, example 2. So you're told that is the figure for the diagram. So this one is given as 10. So those are the questions. Calculate QR, calculate angle QRC, and calculate the angle between planes ABCD and PQRS, and D, the angle of inclination between PR and the horizontal. So it goes straight to the solutions. The solutions, QR, you look for where QR is. QR is the same as BC. So it will be the same as QR is the same as BC. QX is the same as BC. So BC is 30. Centimeters. So when you come to work out that, they said you should have known Pythagoras theorem. So you realize QR squared will be equal to QX squared plus RX squared. So QR squared will be equal to QX 30 squared plus 10 squared. So this will come to 900 plus 100. So this will give you 1000. So QR will be equal to the square root of 1000. Square root of 1000, which you will need to work out very fast. Square root of 1000. Square root of 1000. Give 31.62. Square root of 1000, which is 31.62. 31.62. We move to the second question. Angle QRC. You note C is somewhere here. So they are talking about that angle. They are talking about that angle. So B, you'll say, using the figure in A, you'll say tan theta. Theta is equals to angle QRC. So you'll say tan theta will be equal to 30 over 10, which gives you 3. Opposite of adjacent gives you 3. So tan theta will be tan inverse 3. So the value of angle theta will give you go back to your calculator. Go to your calculator. Tan inverse 3, which is 71.56 degrees. We move to C. Calculate the angle or between planes ABCD and PQRS. ABCD and PQRS. So you come and look at that. ABCD. So you note there was a slight, you're talking of ABCD and PQRS. So note that if we have this plane, if we are to prolong this plane, if we are to prolong that plane would look the same as, it is still horizontal to plane PQXY. So you realize plane is horizontal to plane PQXY. So when you talk of this angle, since it is horizontal to this, even if you project this PQXY, so they are talking about the angle between ABCD and PQRS, PQRS, PQRS. So it will still be the same as this angle. You can tell that angle to be angle alpha. Angle alpha. So you'll come and the angle in question will still be this one. You'll have your XR, which is 10, and you'll have your Q here. Because I've said this plane is still horizontal to this. It is still horizontal to that. So if you project, it will still meet this one at the same angle. So you'll come and say this one is 30. That is angle alpha. So you'll say tan alpha is equal to 10 over 3 over 10 over 30, which is 0.3333. So alpha, that angle will be tan inverse 0.333. So you work out quickly with your calculators. You get 18.43 degrees. That's the angle. Angle of inclination between PR. They are talking of these. So this is PR. This will be X, RX. Look, Lana, RX is 10, but I need to find PX. PX, if I have this as 30, 40 and 30, PX is equal to the square root of 40 squared plus 30 squared, which is the square root of, add the two, 1600 plus 900. So PX is equal to the square root of 2500, which is 50. So I get my PX is what? 50 centimeters. I can call this angle theta. So if they want that angle, I'll take tan theta is equals to opposite